Thank you very much. So sorry about all that, and I'm just going to start running through this. So what we want to discuss today about impact evaluation is a brief definition. I want to talk briefly about how we design an impact evaluation, what the methods, what are some of the methods that are available there, and I will wrap up in the last session. So throughout the presentation, I'm going to use conditional cash transfers as an example of something that we can evaluate, just because that's where my experience comes from. So conditional cash transfers are these programs that give people money so they send their kids to school, for example. So this is cash conditional on giving on an outcome, and that will be sending kids to schools. So impact evaluation is something we use when we have a group of people and we do something to them. So there is an intervention. In the case of conditional cash transfers, it is giving them money, and then we're hoping to see some outcome. So there is a time component of impact evaluation, and we basically have 3 stages. The first one is the baseline, before anything happens. Then we have the intervention, just when we do something, and at the end we have an outcome. So the aim of impact evaluation is basically measuring the effect that whatever intervention we perform has on our participants, and hopefully being able to infer about what will happen to the general population when we do something like this. So in the case of conditional cash transfers, is if we give people money, we're hoping that the school attendance increases. So what we measure is to what extent giving people money, so just the fact of giving them money, leads to an increase in attendance rates. So there are 2 main issues that we need to tackle when we want to measure these kind of things. The first one is the counterfactual, which is basically we don't see what we want to see. And this other one is selection bias. So I'll start with the counterfactual. So here we have, we have the average participant at the beginning of time. So we're assuming that they have this attendance rate to school. And then we give them money, and we see that their attendance rates increases at the end of the period. So what we may assume is that if we compare the attendance rate before and after the treatment, we will get a treatment effect. But then one problem is that in reality, in the absence of a treatment, our participants will have gotten only here. So in the absence of a treatment, the increase wouldn't have been as high as we observe. And that is actually what we want to measure. We want to measure what will have happened to our participants had the intervention not happened. So this is the treatment effect, and this little orange dot, is the counterfactual. What will have happened to people in the absence of the treatment? Another option that we can think about is that we could compare participants and non-participants. So participants are those who received the money, non-participants are those who didn't. So if we compare those 2 groups at the end of the period, we will think that this is the treatment effect. But then the problem is that our participants may have started here and came here, and our non-participants may have had started at a different point. So is this actually the treatment effect if one of the groups started with an advantage? And again, the problem is that this is not exactly what we want to measure. What we want to measure is what is the effect of the treatment had the treatment not happened. So that is the problem of the counterfactual. The problem of selection bias is basically that we have participants and non-participants, and then at the beginning of the time we think they're exactly the same, but for some reason that we cannot really see, our non-participants are different, and that these things that make them different may also be related to the outcome we want to measure. So for example, they come from families that value schooling more than the families of our participants, and therefore they were more prone to attend school at a higher rate, regardless of if they receive or not receive the intervention. So it means over time, our participants will have gotten to an outcome. This will be the counterfactual, and our non-participants will have gotten to another outcome, which is what we can observe. And if we give them the money to both groups, they may also have gone to different places, so different levels of school attendance. So just to summarize, the problem of the two issues is basically that we can't see what we want to see. So what we see is basically we give some people the money, and for those people we see how they changed. But we cannot see how will these people have done if in the absence of that treatment. Simply because if we give them a treatment, there's no way of coming back to that. So that's the counterfactual, not seeing what the outcome would have been for our participants had they not participated in our experiment or program. And selection bias is basically the fact that our non-participants can have an outcome that is very similar to our participants' outcome, but it can also, it is not necessarily the case. So they can have a completely different outcome, and we really don't know. So the solution that people came up with was, well, if we compare the treatment and the control group, we know that there are two components there. The first one is the treatment effect, which is what we want to see. That is the comparison between what happened and what would have happened in the absence of a treatment. And there is another component, there is the selection bias. So the methods that we're going to see is basically they're trying to address the selection bias, because we know if we get rid of it, we end up with the treatment effect. So another way of saying the same is we know this is the change over time for our participants, and this is the change over time for our non-participants. And we know that if we compare this, there is one bit that is omitting the selection bias. So in our case, the selection bias means that our non-participants tended to have a higher attendance rate. And then if we incorporate that in our calculation, we can have the full treatment effect. So that is what is impact evaluation. And then let's try and find out how we can design an impact evaluation. So these are just briefly very basic steps of what to consider. So we know we have a baseline, and in that baseline, we need to divide the people that we see into a treatment and a control group. So here they are the treatment and they are the control group. The treatment receives the intervention and the control group doesn't. So what we do at the baseline is we measure them. Then we provide the intervention, and then we see the outcomes at the end of the period, and we measure them again. That is the basic design of any impact evaluation. So there are many things that we need to consider. First, we need to know what to measure and how are we going to measure it. So are we going to take, is our outcome of interest attendance rate, or is this maybe sense of belonging, or is this any other outcome? And what are the characteristics of the students that we want to measure to? There is also the issue of timing. So how short or how long do we wait between we give participants our treatment and how long will we expect them, that treatment, to make an effect that we can see and measure. So if we give them money, are we expecting them to increase the attendance rate tomorrow, in a week, in a year? And then if we wait for too long, are we sure that the only thing that we can see happening there is the effect of our treatment, or is there something else in there too? We need to decide who is the control group and what estimation method we are going to use. So what we're going to see next is that different estimation methods may need different designs. So that's why it is important that we consider how we're going to analyze the data beforehand, before implementing the intervention and before collecting the data. So we also need to consider to be careful about the implementation. So we need to make sure that only our participants get the treatment, that is, there are no spillovers, and that those who are supposed to get the treatment actually get the treatment. So for example, with conditional cash transfers, if we're going to give the money to the family, we need to make sure the money goes to the member of the family that is actually making those decisions about school attendance, and not to a person who will just do whatever with the money and we wouldn't see any outcome. And finally, we need to make sure that our treatment is the only thing that is happening to our participants. So we get rid of any other things that could have happened. So for example, within school settings, if we're doing an intervention about teachers training, we need to make sure that that's the only thing that is happening to the participants and to the control group. So if you want to jump in, I think this is a good time if I need to clarify anything.
Beatrice, people can type ideas into the chat forum or just call out to you now.
As you prefer.
Yeah. I think probably keep going. It seems a little bit quiet there, but that's fine. We can also come back at the end if we have time for some questions too.
Okay, perfect.
Right.
So we are going to explore some of the methods that exist to analyze to measure basically the impact of a treatment. These are not the only methods that exist, but they are the most popular methods. So the first one is called randomized controlled trials. And what we basically do is to assign participants and non-participants randomly. So the ideal is that we have two stages of randomization. So the first one, we take a sample of the whole population. And then for that sample of the population, we assign randomly students or our participants to a group that receives the treatment and our non-participants to the group that doesn't receive the treatment. So we need the two levels of randomization because the first one assures that we have external validity. So it means that we can generalize the findings to the overall population and not only to those who participated or not participated in our program. And we randomize the treatment because that's the way in which we avoid selection bias. So if you think about it, there is no characteristic of an individual that makes them more likely than any other to participate in the program or to receive the intervention. So the assumptions for these methods are, first, that everyone in the population has the same chances of being treated, and that translates into our randomization work. There are many things that can go wrong. So one that is very contentious is ethical issues. So with conditional cash transfers, for example, we know that giving money to a part of the population is going to have a benefit for them. So how can we decide who are those participants, or how do we prevent some people from getting the treatment when we know there's something beneficial for them? There's also the problem of controlling for spillovers. There's the problem of selective attrition, which means that some people drop out of the program, and that fact that they drop out is not random, it is linked to some characteristic that is also linked to our outcome. So, for example, those who drop out from the program are those who are also more likely to drop out from school. And then there is the problem of having participants that are too similar to each other, so we don't have enough variability to estimate any change. So if we go back to our strategy to find the effect of the program or the treatment, what we have is we randomize the allocation of participants to the group. So that means we get rid of the selection bias, and when we compare the average treatment, the average outcomes for the treatment and control groups, we know that we are estimating the treatment effect. And again, if we see this from this perspective, we can see, sorry, I'm just trying to move this. So we can see that when we compare our outcome the outcome of our participants with the outcome of our non-participants, in reality, what we are comparing is the outcome of the participants with the outcome that the participants will have had in the absence of an intervention. That is, we are technically revealing the counterfactual. So the next technique is propensity score matching. And propensity score matching tackles directly the selection bias by modeling it. So what we do is, first we say, I know that the probability of a participant to be in the treatment group is affected by these variables that I can observe. So I model that and then use those probabilities to find similar people. So I try to find who will have, if I have this participant, I try to find a person who didn't receive the treatment that is as likely as my participant to be in the program, to be treated. So there are many ways in which we can find the match. So I can try to find the next person with the closest participation, or I can create a mixture of the characteristics of the participant. So it's like an artificial participant that has the same probability of participating as the people who got assigned to the treatment group. The problem with this is that we have no external validity. So it means that we can only see we can only estimate the treatment effect for those who were treated. We can't guarantee that the same effect will have happened to the general population, to other people who did not receive the treatment. The assumptions here, there are two key assumptions. So the first one is called conditional independence, and it basically means that the only reason why my participants are assigned to the treatment group and not to the control group are those variables that I said that model the probability of participation. And the other problem, the other assumption is that we find a large enough number of people in the control group who are similar to those in the treatment group. And that's called common support. So what can go wrong is basically we may find that the assumptions don't hold. So, for example, I can only observe gender, age, and socioeconomic status, but it happens that for example, the program was announced on a newspaper, so only people who read the newspaper were assigned to the treatment group, and therefore those who are in my treatment group were also more prone to read. And maybe that means they value education a bit more, and that's why they will send the kids to school more often. And like there are many stories that you can make up about how there is something else that you don't see that is affecting the probability of people to be assigned to the treatment group. Another problem is that we can have participants so the treatment group is really, really different from the control group, so there is not enough common support. So for example, with conditional cash transfers, if they are only allocated to the poorest part of the population, we may find that we don't have people in the control group who are as deprived as those who were in the treatment group. And the other problem is that even if we say, I match this participant, this person who was treated with this one who is in the control group, maybe they are not similar enough. So one had a probability of participating of 80%, and the other one had a probability of 0.1, so 1%. So how does propensity score matching work? So we have our treatment group, and we basically create an artificial control group according to the probability of participation. So when we do this, we know that once we have modeled the probability of participation, we got rid of the selection bias. And when we make this comparison, we have the treatment effect. And again, this is the comparison that we're making. We're comparing the outcome of our for the people who were treated with the outcome of the people in that artificial group that we created that matches them. And we know that that artificial group basically represent the counterfactual. So they represent what will have happened to our participants in the absence of the intervention. So the next method is difference in difference. And this method focuses on the change that participants and non-participants experience. So those in the treatment and those in the control group. How much do they grow? And then we are going to compare them. In contrast with the other methods that we have discussed so far, this is the first method that requires longitudinal data. So we need to observe both participants and non-participants, so treatment and control group. We need to see them before and after the intervention. And if our groups are not similar, are not the same, if for some reason we can take the same people, we can follow them over time, we need to have, for example, 2 different cohorts, but those different cohorts of students need to be similar enough to each other for this to work. So the trick here is that we take out the selection bias just by calculating the difference. This is a method that can be combined with the previous one, with propensity score matching. And there are 2 assumptions about the selection bias. So the first one, it is that the reason why our treatment group got selected into the treatment group doesn't change over time. And the second one is that the selection bias is adding up. So it's not a multiplication, it's not an exponential function, it is just a sum. Sorry. So there are 2 main things that can go wrong with difference in difference. The first one is attrition. That means our participants go away. And there can be different trends. So this basically means that here we're assuming that in the absence of the treatment, our participants using the treatment group will have grown at the same rate as those who are not in the treatment group, so those who are in the control. So if we see it like in this phase, we are comparing the before and after of the treatment group, the before and after of the control group, and we just calculate the difference between them. And when we calculate that difference, we get rid of the selection bias. So if we see it here, we know that this is how much our treatment group grew over time in terms of school attendance. And we know that this is how much our control group grew in school attendance, so they didn't receive the treatment. And we're saying this difference, so this extra bit that our treatment group grew, we can say that it's just because of our treatment. And the assumption is basically, that's why it's called the parallel trend assumption. It's basically they will have grown at the same rate. So this line and this line are the same in the absence of the treatment. And the last method that we want us to discuss is regression discontinuity. So this is based on a selection criteria. So if our assignment into treatment and control group is the result of an indicator, so for example, the income, and we decide that those who are below the poverty line are those who are going to get the treatment, we have a cutoff point at 2. This means that we are directly addressing the selection bias and actually using it to identify our counterfactual. The problem is that we are only going to focus on those participants who are very near the threshold, so the $2 threshold. So it means that we don't have external validity. We can only estimate the effect of the treatment for those who are in the boundary. So there are 2 key assumptions with this method. The first one is that we have a really clear-cut selection criteria. So if we say people who are below or above the poverty line, and that poverty line is $2 per day of income. And we are assuming that there is no way in which our participants can change their income so they can get into the treatment group. And that's the assumption of no gaining. So when we are seeing it in our graphs, if there are clumps of people who suddenly seem to be just above the selection, or well, below the selection threshold, that is an indicator that people can be doing something just to be part of the treatment group. So for example, people can game that criterion. So something that happens is if people who are, if we're measuring just the income of the people, and it is mostly casual workers, so they decide that they are not going to work in the next 2 weeks, just while they are deciding who gets selected into the treatment and the control group, so they can classify as someone who is below the poverty line. Another problem can be that selection rules are not really enforced. So for example, I don't know, they say we're going to just admit people who are below the poverty line, but they said, okay, you have a 2.01 income, so I'll let you be in the treatment group. That cannot happen. And the other problem can be that within our range, we only have a few observations that are really near that threshold. So the way it works is we are going to focus our attention to the treatment, the comparison between treatment and control group, only for those points that are really, really close to the threshold that determine the selection into the treatment. So when we do that, we know that we're estimating the treatment effect because we're saying there is just in that boundary, it is because it is an arbitrary cutoff point, the selection is effectively random. So there's, and that's why the assumption of non-gaming is so important, is there's nothing that the participants who are just around that threshold are really different. It is just randomly that some got above and below. So if we graph our selection criteria, so again, let's make the example of the poverty line. So I'm going to say those who are below the poverty line get into the treatment group, and those who are above do not get into the control group. So we have these participants in the control group, and these ones are in the treatment group. So we can see why the name is regression discontinuity, because we will expect a sudden jump just right near the vicinity of the threshold. So we are going to focus on that threshold, and what we have is that those little points that are near enough act as our counterfactual. So that is, we assume, what will have happened to our participants in the absence of the treatment. Okay, so just wrapping up. We have seen that before and after comparisons are unlikely to reveal the impact of our treatment because of two issues. First, that is not what we really want to see. What we want to see is the counterfactual, which is what will have happened to our participants had they not been in the treatment group. And the second problem is selection bias. So that is, the people who get into the treatment group are different to those who get into the control group for some reason that I may or I may not know. And that reason affects the outcome I want to measure. We have also seen that there are different ways in which we can go about our analysis. So we have randomized controlled trials, which is randomly assigning people to the treatment and control group. The other one is propensity score matching, so directly modeling those variables that make participants go to the treatment or the control group. The other one is regression discontinuity. This is just looking at that threshold And the last one is difference in difference. So checking the growth patterns and assuming that the difference in growth can be attributed to the treatment. So what all these methods have in common is that we need a control group to be able to have some sort of counterfactual. And in the impact evaluation literature, simplicity is rewarded. So in this literature, basically, if you need to go to really fancy methods, it means something went wrong when we were doing the evaluation. This is also a very small component of what we need to do when we have an intervention. So for program evaluation, which is broader than impact evaluation, we also need to have monitoring, a monitoring scheme. So it basically means we need to be attentive to many different outcomes. We need to be checking for spillovers. We need to be checking for side effects of our intervention and many other aspects that imply a whole program evaluation. Another is the cost effectiveness analysis. So here we have not put a price tag on any of these. Cost effective analysis will mean it costs us $5, but we're getting $10 in return. And we are not going that far. This is just saying, I think we actually made a change with this intervention that we designed. And I'm just going to leave you with resources. So JPAL is the research center of the recent Nobel laureates in economics. They do randomized controlled trials, and they have a research option with tons of materials that you can check. There's also a handbook from the World Bank, and it includes the data code for all the methods and some more that we discussed here. There's someone who did the job of translating the code that is provided in that handbook to R. And there is also a very useful workflow that tells you what kind of method you should use in your specific circumstances by the OECD. And those are linked there. And that will be it from me. Thanks.
Fantastic. Thank you so much, Beatrice. It's not an easy task to be presenting from a room online where you're seeing images or names just up on the screen of the participants. So I think you've done a fantastic job of helping to clearly step us through the different aspects of the methods and some of the issues associated with those methods. And yeah, as we mentioned before, some people are just beginning to engage with the ideas around impact evaluation. Other people are a little bit more advanced. So I think this is extremely helpful, and especially there's a recording so people can go back and have a look and think about the ideas that you presented again. So now I'm going to open up to the group and invite anyone who'd like to make a question or comment in relation to the presentation that Beatrice has just shared with us. So, and that can be, feel free to jump in and to ask it verbally or to type it into our chat section there. And if you could turn your video back on, that's a really nice way for us to be able to connect with each other and to see each other. Yeah, Umesh.
Hi, Beatrice. First of all, thank you very much. Your presentation was so easy to follow. I think most of the things make such good sense. So congratulations to do it in, like, even though you didn't have enough time. I have few questions, but just a couple of questions I want to clarify. When you talked about counterfactuals, you said there are a few variables that can impact on the treatment. Like, it can enhance the impact of the treatment, which are confounding variables in my view. So how do you put that in your equation? Do you say that you need to know about that? Because you can't take, like, most of the time when you're doing studies, there's so many things happening in a school. So do you need to know about them and that's you put that in your equation, or what do you do? That's my first question. And my second question is, when you talked about PSM, did you say that you can create an artificial group, control group, and you don't need individuals for them. And so you can run an experiment and you create an artificial group and you conduct your experiment and you say, if there was a control group, this is what could have happened to this group compared to an experimental group. Just those two questions, please.
Okay. So the first one with the confounding variables, so that there are two ways. You can, in essence, basically include them in your equation, into regression model, and you're basically controlling for them. So if in practice, this is as simple as a mean difference, but if you need to condition on observables, then you can do that.
Oh.
So yeah, it is the simplest way is a regression model with only a simple regression model. The more complicated one is you include controls. You can incorporate them in all the methods. But in general, there is the assumption that those variables will be the same for those who are treated and those who are not.
Okay.
And then with propensity score matching, we are in effect creating an artificial group, but we need to create that group based on people who did not receive the treatment. So we do need to, it is based on someone. So we do need data from the control group. So ideally you collect that, but you can do something like you have a survey that happens to be from students who are similar to your students, and you create you use propensity score matching in that group, even though you didn't collect the data about them yourself. It is a possibility, but I think it is kind of frowned upon. So if you can, yeah, like it will be harder to get it published, basically.
Okay.
But you can.
Good. No, thank you.
Thanks, Himesh. Other questions or comments?
Can I ask a question, Amanda?
Yeah, sure. I can't see who's saying
It's
that.
Janet Skull.
Oh, yeah, Janet, thanks.
Thank you, Beatrice. It's really nice to have this sort of presentation and to open us up to a range of different sort of methodologies for our research. And I might have missed this, so apologies if I did. But can you talk to us about sort of sample sizes that are relevant for this type of study? And just so that we get a sense of, you know, I guess the scale and scope of what we'd be looking for in terms of participant sample sizes.
So I didn't mention it, but yep, sample size matters. So same assumptions in general about sample size that apply to any basic statistical analysis. So the 30 participants rule of thumb applies, like 30 observations. But I know, and I don't know if Zoe is here, but there are other methods that can cope with a smaller sample size. But yeah.
Beatrice, to clarify, you said a minimum of 30 participants to use RCTs?
Yeah, but I mean, these are designed, and the method will work better the bigger the sample size.
Mm-hmm.
But yeah, I think as a general rule of thumb, 30. You see this in really, especially randomized controlled trials, because there is funding from, for example, the Gates Foundation, and there are different people. Like J. Paul gives also a lot of money for these kind of evaluations. They are normally on really large proportions of the population.
Mm. Thanks, Jenna. That's a really important point. We have time for probably one more question or comment. Tick, yeah.
Thank you very much, Beatrice. That was very helpful. The approach of regression discontinuity essentially begins with a form of purposeful sampling. rather than random. So I'm just wondering how then that sits beside the sort of classic conventional textbook 1960s Campbell and Stanley views of purposeful sampling.
I think it is exactly that, because we have a selection criteria and that's what we're using. And then it is basically the same problem. We have no external validity. So basically we can estimate the impact for those people, but then generalizing beyond that is not possible.
Okay, thank you.
I think you're muted, Mandy.
Yes, there's a rookie mistake there. So if people are interested to follow up with you to have a conversation about the methods that you presented today, I'm imagining that that's okay.
Yes,
please. Because yeah, we had limited time, and there's a lot, and obviously, you know, you've unpacked that really carefully for us, and there might be particular aspects that people would like to follow up in relation to their work. So that would be great if they can contact you. And thanks again. I think it was really informative, the way we put it together, and really helpful for us to start thinking about the alternative perspectives that we bring to our own research projects as well. So it's great to have you as part of the team, and it's great to have you have this presentation today. I'm going to, I'll just check the chat in here. So there's a couple of messages here. Yeah. So there's other people who had similar questions. And so we'll send around a link for the recording so that people can get access to it again. And thanks again. We look forward to more opportunities to be able to work with you and to hear from other people within the faculty related to the research approaches. So I noticed now that there was a message that's just come through on the email related to the question and answer sessions. So, and I imagine that's where most people are going off to now. So thanks again, and look forward to the next opportunities to see everybody. Thank you.
Thank you. Thank you for coming, everyone.
Thank you.